Hi everyone, welcome to Cloud Native London. This is Cheryl Hung and welcome to our April 2021 event. We're going to have 3 fantastic speakers tonight, but first of all, we're going to just listen to some music for 15 minutes. So feel free to grab a drink, chill out, and yeah, we'll kick off in about 10 minutes, 10-15 minutes time. Hey folks, this is our 1 minute warning. We're going to kick off Cloud Native London in just a moment. So sit tight, make sure you've got a drink, coffee, beer, whatever floats your boat, and we'll start in just a moment. Just as a reminder, if you want to meet some of the other attendees and hang out live and watch this together, then you can go to this link, oicheryl.com/r. This goes to a service called Rambly, where you can, it's like a little 8-bit game where you can walk around and talk to people and watch a Twitch live stream together. So once during the break at 8:15 UK time, I'll be back on Rambly and hopefully I'll meet some of you there. If not, then hopefully on YouTube or on Twitch. We are pretty much at 7 p.m, so let's kick off. Just a reminder of who we are. Cloud Native London is a strong, open, diverse developer community around the Cloud Native platform and technologies, usually based out of London, but like everything else, based virtually at the moment. My name is Cheryl Hung. I'm the VP of Ecosystem at CNCF, which is the home of Kubernetes, Prometheus, and lots of other open source technologies. You can find me on Twitter at oicheryl. Tonight we have 3 speakers. Batel is going to be our first speaker. She's going to talk about CI/CD pipelines for Kubernetes. After that, we're going to have Alex, who's going to talk about performance and benchmarking cloud native storage. Then we will take a 15-minute break. And then Matt will finish up the night to talk about continuous security and building security into your pipelines. And we will wrap up at 9 o'clock UK time. But first of all, I want to hear a little bit about you. So if you have a phone or laptop or tablet, whatever handy, please go to this link, oicheryl.com/p. This will redirect you to a service called Poll Everywhere, where you can put in your name and just follow along with some questions and sort of help everybody learn a little bit about yourself and what you're doing. So tonight we've got 3 questions about you and then 3 questions about how you use Cloud Native. So once again, this link is oicheryl.com/p. If you forget that link, you can also go to this slightly longer one here. So first question, is this your first time at Cloud Native London? So you should have 2 options that you can see on your screen, a yes and a no. Just hit whichever one, whether this is your first time or whether you've been here before. Cool. I'm going to give people a few moments to figure out how to use this Poll Everywhere service. Okay, looks like the no's, the returners, are in the lead at the moment. See some more votes coming in. A couple of yeses coming up to 22%. Okay, I think it's slowed down a bit, but again, if you missed the link earlier, you can also use this slightly longer Poll Everywhere link to get a link to this poll. You don't need to download anything. It's just a web page, just to help everybody hear a little bit more about you. Okay, so it looks like 75% are returning to Cloud Native London, 25% this is your first time. So particular welcome if it is your first time, but again, really happy to see everyone back again at Cloud Native London. Let's go to second question. Where are you right now? So you should see a link, image of the world, and just tap on wherever you are in the world. I think one of the great things about being virtual is that we can have a much wider range of people come in and join these events. So actually there's definitely some positive to going virtual. Unless this person really is in the middle of the sea, I think you can fix your answer as well. So I think you can undo. Yeah, there we go. So I see someone from the US, someone in India, most people, I think UK and Ireland. Is this Germany? I feel this bit always tests my knowledge of countries. Cool, give a few more moments for people to register where they are. Israel. Okay, seems like, I don't know if this really is in the sea or if this is a mistake here or if it's just someone trying to get on the edge of the land, but either way, it looks like we have mostly UK tonight and a few folks everywhere else. So again, awesome to have you. Let's go to the next question. What is your job title? So just pick whatever is closest to what you do. So architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And if it is anything else, then feel free to put into the comments on YouTube or on Twitch what you do. So it looks like architect and SRE is kind of in the lead. Actually quite a nice spread tonight. Again, I'd be very interested to see what you do if you put in other. Just give 10 more seconds to see if any other answers come in. Okay, SRE, DevOps/DevOps engineer pulling ahead. We usually mostly have SREs and architects as our audience. So this is pretty cool. Okay, for the next 3 questions, I've asked each of our 3 speakers to submit a question that they want to hear about from you. So our first one is from Batel. And as we see the answers, I want all of our speakers to come in and just comment on what the answers were and whether you expected it. So the question is, what is your biggest Kubernetes challenge? Is it that Kubernetes has too many pieces? There are challenges with Kubernetes monitoring and performance optimization. Kubernetes reduces everything to code, or all of these? Batel, I'm really interested. Why did you pick these particular answers?
So actually I heard a lot of answers whenever we're asking for these questions, and those were the most popular on events and stuff. That there was some people that saying that there are too many pieces, it's too hard to make it. Some of them saying that the monitoring is not good enough. Some of them, of course, talking about the code. And I guess that some people will vote for all of these, but let's see. Okay, we got it.
I feel like we should have had an answer for like something else, anything else.
Yeah, always. And let's see the comments on the chat or something. If anyone think there is something else that is really, really challenged with Kubernetes, please share with us on chat.
Is this what you expected? That 50+% said Kubernetes has too many pieces?
I actually think for more for all of these and less for Kubernetes has too many pieces, but yeah, kind of.
Alex, Matt, any thoughts on this?
Yeah, I'm not surprised. I would have thought the obvious challenge around Kubernetes was dealing with YAML, but
really, it's not so bad. Some of the developers love YAMLs.
Indentation.
So annoying.
Yeah, I would have suggested something around visualization, things like metrics and being able to view the details of how a service mesh or a cluster is deployed is so hard sometimes.
I guess monitoring maybe covers that a little bit.
Yeah, but it's not so challenging. Yeah, I actually expected for less than 40% for monitoring. that are pretty good tools in the market.
There are a lot of good tools. I think it's still complicated, so complicated to get it right.
Yeah. Okay, I agree.
Awesome. Okay, I think we've slowed down a bit now, so let's go on to the next question. Have you had to diagnose a storage-related performance problem before? Just yes or no?
Wow, okay.
So this question comes from Alex. What do you kind of think of when you think storage-related performance problems?
Well, so we often, you know, we often kind of have this infrastructure dilemma where, because storage is providing, is providing that stateful service to most applications, whether it's a database or a volume or an object store or whatever it is, that very often the scalability or the performance of an application is going to be somewhat related to storage or how you're accessing the storage. And so, I was going to posit that if you think you've never had to diagnose a storage problem before, you've probably maybe missed the fact that something was causing that storage problem. And that could also be, say the network or something else. But ultimately, I've got a very firm belief that most applications will have some sort of storage dependency, and most performance problems end up being network or storage. So that was kind of the concept here.
It seems like 2/3 of people agree with you that they've had some difficulties with the storage and performance. If you're in the third that don't, then I would love to hear more about, again, like maybe you don't use storage. Maybe, I don't know how that would work, but
maybe you don't use computers.
Yeah. You're looking at this on a stone tablet right now.
Yeah.
There's such thing as a stateless application.
Heard that one before. Okay, let's go to our final question. Where have you integrated security testing into your Kubernetes deployment practices? The Kubernetes deployment process. So your options here are your local dev environment, your source code management, CI/CD, admission control, or runtime. And I think this means you can vote for more than one option here. So you can choose all of them.
I think I should have added the "we don't do any security testing" option.
Yes. I'm sure they're
surprisingly common.
CI/CD definitely taking the lead here. Matt, is this what you thought about? Is this what you expected?
So I'm surprised that things like admission control and runtime are kind of emerging, and you do tend to see less of that, even in folks with very well developed Kubernetes environments. I'm surprised we're not seeing more local dev environment testing there, but it might be that because of the makeup of the attendees today that if folks are more focused on the infrastructure side, then they might not be so aware of that. Oh, we got some there, but yeah, I mean, CI/CD is a good place to do it. I think if you're really serious about cloud native security, what you see folks doing is scanning in all of these places because they all have subtly different purposes.
No, I think that makes sense to me. Nobody said admission control at all.
Yeah, I mean, it's still a kind of emerging field, really, admission control. It always surprises me that more people haven't adopted that yet. I think it's starting, but it's just that those kind of technologies are pretty new.
Agreed. Okay, it looks like everybody's filed in their answers. So I want to say that's the end of the live polling for tonight. We'll use the same service to ask questions to the speakers, but thank you for sharing what you do and a little bit about you. Okay, and now I'm going to welcome a few people on to say thank you to them for sponsoring tonight's meetup. So Lizzie, would you like to say a few words for Technovo?
Hi. Yeah, so I'm from Technovo. We're a challenger digital consultancy providing expert partnership and growth without creating dependencies or disrupting culture, which basically means that we like to operate a little differently to other consultancies. We pride ourselves on investing in the talented developers and working together to provide the best possible outcomes for our clients. We work across both public and private sectors on some really exciting transformation projects. And if you'd like to get to know anything more, just find me in Rambly or find us on LinkedIn. I'm happy to talk. Back to you.
Sweet, thank you so much, Lizzie. Humio couldn't make it tonight, but they asked me to say a few words on their behalf. So Humio is a time series log management solution for unrestricted event analysis, which scales to multiple terabytes per day on premises or hosted. Next up, Zan, would you like to say some words for Circle CI?
I would indeed. Cheryl. Hi, everyone. On behalf of Circle CI, my name is Zan Marken. I'm a developer advocate. Circle CI, we are the leading CI/CD platform. We're used by awesome DevOps teams everywhere around the world, and it works with whatever tech stack that you have, from Kubernetes, obviously, to web apps, mobile, or anything in between. So just last week, we announced the release of ARM Compute. So ARM as an architecture is becoming more and more popular, and many vendors are providing compute resources for it. So if you're building, for example, on the new AWS Graviton 2 machines, you can build and test these using Circle CI. So yeah, if you want to check it out, go to circleci.com. Thank you very much.
Thank you, Zan. I believe that Ashley is not here to talk about Palo Alto Networks tonight, so I'm going to move on. Umata also asked me to say a few words. So Umata are a technology recruitment company set up with the sole purpose of doing things differently, to put people first, to inspire confidence, and to spark creativity. And they work with startups and some of the coolest tech brands across the world to help engineers find their perfect role. Alex, you're up for StorageOS.
So StorageOS is a software-only cloud-native storage platform. We're deployed as a container, completely platform agnostic, and provide a bunch of data services like replication and compression and encryption, as well as the automation and self-service to allow you to build anything as a service and move all your stateful applications into Kubernetes.
Perfect. Thank you so much, Alex. And last but not least, we have Aui.
Hi, thank you. I'll share just a little bit about JFrog. We are a DevOps software company. We were founded in 2008. Many people in the DevOps community know us best for our flagship product, Artifactory, which is considered by many to be the gold standard for managing your artifacts and dependencies. Something you may not know yet, though, is that JFrog has a free cloud version of our software available for you to use for your projects, especially for the meetup community. If you are working with Docker, as I know many of you are, JFrog's free tier on the cloud is capable of functioning as a pull-through cache for Docker Hub. And here's the best part. Since JFrog has partnered with Docker, you'll also be exempt from their rate limits on pulls from free or anonymous accounts. Cheryl, can you share the other slide really quick? Awesome. Also, our annual DevOps Global Conference, Swamp Up 2021, is coming on June 1st through the 3rd to EMEA, and JFrog wants you to get in for free. Here on the slide are just some is a QR code, and I'll drop it in the chat as well, so that you would be able to see that also. And we also want to give you an extra free ticket to our deep dive tutorial day, which is typically an add-on ticket, but for attendees today, we would love to give that for free. And last but not least, we have a raffle today for a Nintendo Switch Lite. We are going to be giving that away along with one of 10 limited edition JFrog t-shirts. You can enter by the QR code or the bit.ly link. I'll drop it as well. Now, I wish I could do a live drawing, but I can't. But the winner will be selected randomly within 2 business days, and then we will share the winner on your meetup page, and of course, congratulate you on social media again. Thanks, Cheryl.
Perfect. Thank you so much. And thank you to all of our sponsors for making these events possible. If you want to come and speak or sponsor, go to cloudnativelund.com. We have some speaking slots open from June 2021. And that is it from me. So I'm going to now hand over to Batel.
All right, so thanks, guys. And I'll share my screen in a moment and we can start. So today we're going to talk about CI/CD pipelines for Kubernetes. I believe that most of you heard about it a few times, but let's try to talk about it together and figure out what it is, why we need CI/CD pipeline for Kubernetes. So I don't have a fancy way to ask questions like we had before, just to see the answers in the chat and stuff. I believe that most of you love Dockers, but if you're not, just let us know in the chat. So my first question here is, who likes Docker?
Who doesn't like Docker? Come on.
Right, everyone loves it. It's so easy. And what about Kubernetes? Who likes Kubernetes? And if I was asking this question before 2 and 3 years, I think it was a nightmare for a lot of developers and people. But yeah, let's see some answers. Let's see if we have anything in the chat.
I mean, I gotta say, I love Kubernetes.
That's good enough. What about you, Alex? And then I see that you're still here in our call.
I think everybody loves Kubernetes. They wouldn't be here otherwise.
I hope so. So yeah, I believe we'll have some fun today. And as Ari mentioned, we have awesome raffles. So please rate my talk and enter the raffle. You may win a Nintendo Switch, which is pretty cool. And t-shirts and cool stuff like the t-shirt that I'm wearing right now. It's pretty cool. We love some marvels and stuff. And now I can talk a bit about myself. So my name is Batel Zar. I'm a developer advocate in JFrog. Before that, I was part of the support team and the hybrid solution team in JFrog, which was a dedicated team to help our customers that using the Enterprise Plus. As you can see in the picture, I have an amazing doggy named Benja. And also, actually, I just adopted another dog before a month. So this is Sol, my new baby. And if you want to get a hold of me later, feel free just to find me on Twitter, or you can also email me. And I'm really always happy to help. So please do not hesitate to reach out if you need something. So let's start. Let's have some fun. So CI/CD pipelines. I guess that you already heard about the word pipeline so many times, so I'll try to make it quick. And I know that you're trying to find the best solution for your organization. And of course, we are working so hard to find this specific solution. And automation, exactly the same. We know how automation works. We know that we need automation. We want to add more and more automation stuff because we're humans and we're making some mistakes as always. And what about testing? Some of the developers love it, some of them hate it. But I truly believe that we need to add more and more testing to make sure that everything tested before we're committed and we can automate everything and try to make sure that we're safe, right? And so today we're going to talk about the journey from code to production. There are some companies that are ready for cloud. As you may know, it's much more easier to do all of this movement from the on-prem to cloud. And some of them need to really work hard, right? Like a new application that they need to prepare from scratch because they didn't write on microservices and some small code examples. So application could be, it could be a bit hard, to move to the cloud, but it's not so, it's really worth it. And from my experience, I saw that with customers, it's totally worth it. And there are a lot of tools that you can use in order to help you with this process, like Dapper, for example, which is really cool. So today we're going to talk a bit about this journey. Sorry for that. So yes, and I'll tell you my story. So basically, I wanted to create a scalable, generic, amazing application that can run anywhere with different OS systems, like everyone wants, right? We want to make sure that we can run it on Red Hat and on Windows, SUSE, any OS system that you can just think about. We can easily want to test it, to have it, make sure that everything is up and running. So how we plan it, we wanted to build a Docker image that contains our application. Then we'll create our environment on Terraform and manage everything in Ansible. And would like to make sure that we have, kind of different environments with Terraform. So we'll create different templates. One we'll use on Ubuntu, one on Reddit, and so on. Because we want to be super global, right? So the first step was to create a Docker image. Yeah, it could be a journey of 1,000 smiles begins with a single step, right? So it was a bit tough at the beginning, but then when you get used to it, it's much easier. And I truly believe when we're talking about DevOps for developers, we need to make sure that everyone is aligned. They don't have to be, an expert of Kubernetes or Docker, but the developers need to better understand the microservices and to make sure that they can add a really small part of their code every time and not like a huge feature that are adding, because it can make a lot of problems. And we want to have really small microservices each time. And we want to make sure that we have a testing for any commit that they just doing to make sure that we're protected. And yeah, we really like Docker, but I don't think we can trust it so easily, right? Docker is amazing. It's a great tool and I love it. But if we want to make sure that, can we promise that we're using the exact same image every time? In case that we need to use, in that case, I believe that we need to use a binary repository manager. And I would like to explain you about it a bit more. So as you may know, when using the latest version of an image, it will change every time, right? If I'm just doing a Docker pull, Ubuntu or whatever, any image that we have, it could change every time. And if we are adding a new security patch or another layer, we would like to make sure that everything remains exactly the same. They don't want to break the whole build and get the full image again and try to build it from scratch. So that's why we need to make sure that we have the development and the development testing and the production. So I want to make sure that the image, the layer is exactly the same in all of them. Because let's say that I started with development, I download this specific layer, and after, I don't know, a few days or even few hours, there was a critical security patch, and then the layer just changed. Then somehow it just happened again. So we don't really want to build everything from scratch, right? We want to make sure that we are protected, that we have kind of quality gates, that we can trust it. So in that case, we want to build only once and make sure that we are using the exact same image. So we will use a binary repository manager that will contains our artifact, our image, and our layers. And we'll make sure that you're using the exact same layer every time. So for that purpose, we need the quality gates, separate registers per environment. So we have the integration environment, the system testing, the staging, and production. In that case, we need to make sure that we are also protected and nothing from our integration will leak to the staging or someone will move something from place to place, because we want to make sure that we're using only the specific version that we created for the integration and so on. And what will happen in this quality gate and all of this journey? At the beginning, of course, we'll have tons of dependencies, right? And tons of testers and things that we added for the first versioning that we just created for this application. Then when we will move to the system testing, it will be a bit smaller because we will try to clean up some stuff that we don't really need. And we will move from code that it might be not secure enough, and we'll change some components and stuff. Then we will move to staging, which will be very similar to production. Sometimes it will be even exactly the same, but we want to make sure that we're making a smaller and smaller package every time. And we, of course, want to make sure again that we are safe and whatever we have in our integration will not go to any other stage. So it will look like something like that, right? We're the developers right here. We are deploying our code to our virtual repository. And from the virtual repository, in case that we need any dependencies and stuff, we'll resolve it from a remote repository, like Docker Hub, for example, or any private remote repository that we have in our organization. Of course, we can combine any other repository like Docker registry in Azure and so on. And we also deploy to our local repository. So it will be like the stages that I mentioned before. We have here the Docker dev local, and we have the staging and testing and the Docker prod, and we can promote them from time to time. So whenever I think that I made a huge change from, for example, from my testing to my staging, I'll just promote it and keep the partners that I want from one place to another. Then whenever I want to get another developer that will get my code, it will take it from the virtual that can grab it very easily. And of course, we have some benefits like caching mechanism and so on. So yes, we got kind of a win-win situation. We have a single point of access to multiple registries when needed. I can create a virtual repository with different locations, so I can point to different places to get my dependencies and my artifacts. And it's completely isolated environment. Whenever I'm creating a repository, it will be only for the specific stage, so I don't need to create something that contains some of them together, unless if I want to have kind of a virtual one. And it's immediate and free promotion, so I can easily just move between the stages and change it very, very easily. So our second step, let's create a Kubernetes cluster, right? That's what we wanted to. So in that case, I use Google Kubernetes Engine and Terraform and Amazon AKS. So I just deploy my Docker image to the cloud. It looks like it's very good. Everything was up and running. And then after 5-6 minutes, I tried to run it again and it didn't work. Something just crashed. So we start to debug it, right? We try to see what goes wrong. What is the difference? So we use E2 standard 4 and M4X large, which looks pretty the same. So we use the same resources, same CPU, same memory. We really try to deep dive and see what goes wrong, right? We're using the same image, just a different provider. We're using the same application, nothing changed in the application. And then we go to the first step, and wait a second, sorry. All right, so yeah, we have the first step with the Ansible script to manage our requests. So we took our request and everything was fine. I just added, to my list of the Ansible, tons of IPs, start to run some REST APIs. And again, I'm not sure why it didn't work as well. I try again and again to see what's going on there. And yeah, my team was so stuck, we created different environments for different testing with different IPs. And we got a lot of comments. Some, was very positive that everything is working, but the specific environment is not so good. And we need to make sure what's going on there. And, the critical environment and all of this stuff that came together. And it's super slow, but it looks exactly the same. We use the same template. We use the same application. It can't really go wrong, right? It's nothing that you really expect for. So as I said before, in one of the server, everything works like a charm. As you can see, he's super quick and it was great. But on the second server, everything was so slow. We really tried to figure out what's going on there. So we started again our investigation, like we saw in the beginning with Terraform, just a missing CPU there. So that's why we need metadata. I truly believe that we need to collect as much as possible metadata to get information about my application. So here's an example from Artifactory with a Docker image that's called Web DevOps, as you can see here. And I have my manifest, and I try to collect as much as possible properties in my image. So the first property here is the build name, which build created it, the build number, how much time it runs, the build time step, and the Docker environment. That's what I added to see where exactly it's running, and if I passed the test, for example, what was my VM region and VM time. And that's why I'm thinking it's super important. I want to make sure that I can track everything down very easily in case that I have something. That's a really nice tool that I can use to see what exactly going on there. So during the build, we collected the metadata. I see that in the manifest, the Docker environment was EKS. and the VM IP, VM region, and VM time, and so on. So that tool provided me a nice information about the VM that didn't run as well, right? Whenever you're hearing the QA team, everyone just saying it's not running, it's not running. Sometimes it's even hard to provide me the IP and the information to dig dive and see where is my problem. So first of all, we found which IP is related to which version, which vendor, sorry for that. And we saw the manifest here, the manifest exit right here, which was, we changed the VM region afterwards because we had some issues with the region. So then we also tried to change the VM size. We really tried almost everything you can think about, even the stupidest thing that you can think of. It was like the zone and the machine type, even the name somehow. We tried almost everything. And then we did their answers. So when we changed the VM size, the request worked as expected, which was super weird. And we was like, what can really change by the VM size and the request? It's working the same on different vendor and so on. So we really didn't expect for it. And then we heard that there is IOPS limitation. So I believe that most of you heard about IOPS, so I'll just make it quick. IOPS are the information, and it's basically the way to operation. It's basically operation per second, and pronounced IOPS is an input-output performance measurement. We want to try to measure it and use characterized computer storage device like hard disk, solid state, and so on. So basically, in one of the, as you can see in the GCP documentation, whenever I'm using a specific size, I get less IOPS, which makes the request super, super slow. And then we figure out what's going on. We just, upgrade the machine. We saw that everything is up and running. Everyone was happy. And if you want, I can show you a quick demo how it's looked like. So let's go to my Artifactory really quick. And talk a bit about how it's working in Artifactory. So today Artifactory support 27, maybe 28 even, different package types. So here's my setup. Let's click on a quick setup. So as you can see here, we have the Docker repository. Like we saw before, we have different type of repositories. We have the local one, the remote one, which is kind of a proxy, and the virtual, which is kind of an envelope between all of them together. So I can point to one repository that will also pull my dependencies and push them once I want to add any new information. Then when we use our EKS and AKS and GCP environment, I just use the Helm repository. So whenever I just wanted to create my Kubernetes cluster, I just use the Helm here. I put my configuration inside this repository and make sure that I'm using the exact same every time. And then here's my build information. Let's talk a bit about that. Let's see if my Rockstar build is still here. And if not, we'll just take another one. Let's take this one. And of course, for there is no demo without any damage. So let's try this one. All right, something wrong with the demo. Yep. I'll try to take another environment. Give me a second, please. It's the jinx of the demo, right? It's always happening, right? Every time you want to have a quick demo, something shouldn't go wrong.
No worries, Batel. We've all been there.
So I'm sorry for that, guys. I'll try again. And if not, you just need to trust me. So I'll try to show that in the presentation again. But basically, whenever I'm having the build info, I'm creating kind of a huge JSON file with all the information that I needed. And I think the most powerful thing here is the ability to just configure it very quickly and also to create very, very complex queries, right? So in case that I want to make sure that my build passes the QA or a specific stage that I would have in my organization, and I would like to make sure that it's running on a specific machine, I can do that very easily with the build information. And I know, yeah, no demo for today. Sorry, guys. And I I really tried. I don't know what's going on, and I don't want to see you will see too much 4-on-4 stuff. It looks very bad. So I think it's a great time for some Q&A. If you want to share your code, what do you think about it? I know it's hard, so feel free to ask anything.
Awesome. No worries about the demo. As I said, it always happens. Always happens. I'm going to share my screen so that I can put up a Q&A slide. So again, please go to this link at the top, or you can use the short one that I gave you earlier, oishell.com/p. If you have any questions, then you can type them in here. This is like Reddit style, so you can also upvote and downvote. So let's just see if there are any questions that come in. I did see a comment on Twitch. Someone asked if they can get your slides afterwards. So what's the best way to get your presentation?
Yeah, of course. And I believe we also have a record, right? So if you want to share it, you can.
Yeah, but like, should people find you on Twitter or email, or what's the best way?
Yeah, actually, both of them. I'll share with you the details second. Just give me a sec.
Oh, okay. Yeah, I'll stop for a moment.
All right, so here's my details. Feel free to add me to Twitter, to send me an email, whatever you need, either on LinkedIn or Facebook, whatever you want. I'm pretty available. And no questions for today. What's going on? Kirill, anything?
Let's give it a few moments. Oh, person on Twitter said thanks. So
thank you, guys.
Sweet. I'll put up the slide again and let people.
Awesome. So I'm stopping my sharing.
Yeah. Oh, so it was a good slide deck. I thought it was excellent slide deck. Really well done.
Thank you.
Let's give a couple more minutes for people, because it takes a bit of time to type in the questions and everything.
Sure, no worries.
What should we have seen in your demo if it all worked perfectly?
So actually, I wanted to share the build information and the creation of repositories and so on. And as Ari said in the beginning, it's free. So you may want to use it. It's very nice. You can see everything in one place. And I'll really try again to find another demo. And I'm sorry for that. But things can jinx whenever you're doing demos. Any other GCP gotcha? If anyone thinking around changing cloud platform. No, actually, GCP is also great. You know, it's just a specific issue that I had and it's solved. So I'm not sure this is kind of something that should worry whenever you are talking about very, very large environment and very large organization. You probably use machines that are much bigger than my case. That was like, you know, testing and stuff at the beginning, and we figure it out. But actually, I don't have kind of a favorite, favorite platform to use. Whatever works for you. I think all of them are really, really great. Some of them providing you kind of a free trial and stuff. But just play with it. And also Minikube, when it's running locally, it's really cool. So
Okay. Oh, someone else asks, what is your CI/CD pipeline look like for Kubernetes? How does it look like for Kubernetes?
So actually it was very, very simple image that we created of our Artifactory. We tried to move it to the Kubernetes with, just changing the image a bit. And we created the chart and everything we needed for the Kubernetes and just pull it from the Artifactory. So since it was in the same place, I think I can share it with you in my GitHub. I'll try to find it. I hope you can hear me. I just saw my internet connection was unstable. Can you hear me? Should I repeat?
Yeah.
I'm sorry.
Yeah, you can repeat.
Okay, cool. Sorry for that. So actually, I think I have the code on my GitHub, so I'll try to find it and share it here. But it was really, really simple code of Artifactory that we just migrate to a kind of a chart, and we use this chart. And since, Artifactory could be pretty resource intensive sometimes when you're running tons of requests. That's why it doesn't really fit for the small machine that we use on the GCP.
Cool. Okay, let's see if anything else comes in. Otherwise, we can wrap up and I'll hand over to the second speaker.
Hey, Alex.
Okay. One last question. There you go.
Yeah, one last question. I'll do it quick, I promise. So did you find any difference in performance for application from different cloud provider besides the IOPS issue and different OSA? So yes, some of them I can't really expose, but for most of them we found solution. The DevOps team finding it every time, every day they're having anything that's happening on a specific machine, like we're saying as developers, right? Every time it's working on my machine. So I can't think about something that we can really share right now, but sometimes whenever we're using a very intense resource intensive application. So for example, we had an application that required a lot of CPUs like X-ray and so on. And I remember that we have something very, very similar between the cloud providers. It didn't act the same between the cloud provider, even that we use the exact same image, the exact same chart. And yeah, we need to make sure in that case that we have tons of metadata and tons of information to see where exactly we have the issues.
Fair enough. Okay, thank you so much, Batel. Really appreciate you sharing this today. And with that, I would like to welcome Alex. So Alex, please feel free to take over.
Hello. Okay, I will share my screen. Right. So today I'm going to talk about performance and benchmarking that performance in cloud native storage. And I'll start off by saying, performance and benchmarking in general is just a hot topic, and it's a very vast topic, and it can cover lots of different types of storage, and the cloud native environments can make this even harder. So I'll try and demystify it and simplify some of these things, and maybe I'll even do a little demo, but I've actually done a quick sacrifice to the demo gods, so hopefully it will go okay. By way of introduction, I'm one of the founders and the CEO of StorageOS, where we're building a software-defined cloud-native storage platform. And I kind of have two hats. I'm also the co-chair of the CNCF storage SIG, and I'm actually going to be talking about a lot of the documents and information that we've been preparing in the SIG as part of this call. My background is actually in infrastructure engineering, working for large finance houses before embarking on this amazing startup adventure. And I, I'm going to admit I'm a bit of a performance geek, and for the last 20 odd years I've been working on high performance systems and trying to understand and figure out some of these challenges. So this is something very close to my heart. I'm going to put my SIG storage hat on for a second and just do a very big plug. We'd love to get new members and help grow the community. We have open meetings on the 2nd and 4th Wednesday of every month. Everything is public agendas and public recordings, and we often have we're often discussing topics like the storage landscape and topics like performance, and more recently disaster recovery, for example, in cloud native storage. And we also have lots of interesting project presentations from the community too. So strongly encourage you to have a look at the SIG repo in the CNCF and perhaps view some of the recordings. So in fact, one of the first things the SIG had done was put together the storage white paper. And in the storage white paper, we describe a number of different things to kind of demystify some of the things about cloud native storage. So we talk about the different attributes of a storage system, like performance, for example. We look at defining some of the layers that you find in a storage solution, because Kubernetes especially and cloud services add many layers, many abstractions in an environment. We discuss the different data access interfaces, and I'll go into that in a bit more detail, and also some of the management interfaces which control the automation and the sort of composability and declarative nature of cloud native storage. So one of the things that we wanted to define in this white paper were the different storage attributes, and we kind of defined them we defined 5 major attributes: availability, scalability, performance, consistency, and durability. And one of the things that that we wanted to do following this storage white paper was to then create additional papers that focused on particular areas of these attributes, and performance was consistently the attributes that people wanted to dive in a little more, because fundamentally things like the performance operations per second, like the IOPS that Batel was just talking about, or the throughput or latency, are such a big factor in every other aspect of the other attributes. So in fact, the way you do availability and the way you scale and the way you implement consistency and durability all have huge effects on performance and vice versa. So we put together a performance white paper. The link to the Google Doc is on screen. The document is actually open for comments now, so feel free. It's still in draft form. We're still working on it, but feel free to have a read, and if anything jumps out at you that we've missed, or that you think we should add, or that you think we should edit, please feel free to make comments. This is open at the moment. One important takeaway out of all of this is that it's very hard to compare results that are published by a particular project or a particular cloud provider or whatever, without a deep understanding of the test conditions. So the important thing is that you run your own tests in your own environment with your own applications, so that you can actually get a feel of what to expect. And what I'm going to describe is a little bit on how you can run those tests yourself in these environments. In the white paper, we covered different data access interfaces, and there are 2 sort of main buckets of interfaces. There are volumes, which are probably the most well understood in terms of file systems or mount points in your system that you're probably very familiar with. And then storage systems which you access through an API, such as databases or key value stores or object stores. And when we polled the community, we settled on defining performance criteria and benchmarking tools for volumes and for databases, as that seemed like a good place to start. Over time, I'm sure we'll iterate on the document and add other things too. So, starting with volume workloads, some of this might be obvious, some of it might not. But effectively, what we have is applications issuing I/O into a queue onto a file system, and those are typically reads or writes, but there are other types of I/Os, like trim commands or other things like that, as well, that some systems use. Often the file system will be paired with the kernel's page cache, and this means that the file system transparently does a bunch of caching for the application, and that I/O from the file system then makes its way to the block driver if it isn't in the cache, and to the underlying storage system. And of course, this is greatly simplified because there are typically additional layers in there. So, for example, there may be bind bounds in the Kubernetes system. There could be additional volume managers or additional remote connections to different storage environments, which kind of affect all of this workload. And so when you're looking at volume workloads, the authority in this space when you're looking at benchmarking volumes is the FIO tool. The FIO tool is available publicly. It's available as a package from many distributions, and there are containerized versions of FIO too. And all the documentation is online. Now, the thing is, FIO is incredibly comprehensive. So the benefit of that is it can do everything. The problem with that is it can do everything. So if you look at the documentation, you'll see there are several hundred pages with probably several hundred options and parameters and engines and different things that you can do. Everything from doing basic benchmarking to stress tests to even verification and data integrity type testing on volumes or devices. And in fact, because it is actually so complex, I've actually built a little tool which I'm going to be sharing and demoing at the end, which can help you standardize some of the testing that you do with FIO. But when you're doing tests, some of the things that you may want to consider in your environment is whether you're doing reads or writes. Now this kind of sounds obvious, but what we see is, most storage systems have very different profiles for reads and writes, and actually, things might not be as obvious as you'd imagine, because in many microservices-based architectures, where, for example, there are caches like Redis or Memcached or something like that in the mix, you might find that, for example, your database or your application is doing a mostly write workloads rather than a mix of reads and writes, because most of the reads are cached or being satisfied to memory. The other important thing is to understand is the I/O size. So these are the operations, the read or write, the size of the read or write operations. This is typically going to be measured in blocks and are typically going to be measured in standardized blocks based on the file system. Typically, that's going to be around 4K or multiples thereof. It's very important to understand the I/O size because of your workloads, because most systems have restrictions on the number of IOPS that they can implement. Like, in fact, like the example Batel gave in her use case. And so what you can have is you can typically do a small number of IOPS with a really large size, which would give you very high throughput. Or you can do lots of IOPS with a very small size that will give you lots of operations per second. So it kind of depends on your workload. Another thing is to understand the queue depth and how many things effectively can be happening in parallel. So very often applications will be only able to do a handful of things in parallel, especially if it's just using standard files. But systems like databases, for example, can scale to lots of clients and implement lots of transactions in parallel, and therefore testing the number of things that your storage system and your block driver and file system can do in parallel is also an interesting thing to find out. Random versus sequential is again something that is going to be specific to your type of workloads. Things like databases, for example, often have very random small I/O block sizes for their queries and writing to checkpoints into the database. Whereas, for example, very often things like analytics, think Elasticsearch or say streaming systems like Kafka, for example, have very sequential workloads, and sequential workloads can benefit from different caching mechanisms, and therefore can typically provide much better throughput than random workloads. And finally, a word on latency. So in many cases, every I/O is going to take a certain amount of time, depending on the queue and the number of queues. The latency will have a direct correlation with the number of operations you can do per second. So if you have a latency where every I/O is taking a millisecond and you only have a single queue, then you're only going to ever be able to do 1,000 IOPS per second, for example. Moving on from volumes, we look a little bit at databases. Databases have, apart from storage, have two big other components that affect performance, and that's the CPU and the memory. In fact, query processing in most databases is entirely bound by CPU performance. So making sure there are enough CPU time and CPU cores available is key when testing the performance. Of course, like we mentioned, with the file system cache, databases use memory for two things. One, as a cache, but also they use memory to process database operations like joins, for example, and things like that. And of course, the most intensive workloads that hit the storage in a database typically are the write workloads, and figuring out whether your storage is local or remote, or whether you're getting lots of cache misses on the reads, typically affects the overall performance of the database. When benchmarking databases, Sysbench is a really generally good tool. The Sysbench tool can test lots of different components, and there are different profiles, but there are two really useful profiles which we recommend for testing the databases. One is the OLTP read-only, and the other is the OLTP read-write. The read-only, as its name suggests, is mostly select queries, and that tests things like the CPU performance and the multi-threaded performance. And of course, if the database is actually bigger than the cache and the size of the memory, then you're also testing the storage read performance. Whereas the read-write test is a more generic workloads with both reads and write queries and transactions, and you can if all of the reads fit into memory, you might not see any read I/O at all. You might only see write I/O. So that's a really good way of testing the overall system. But of course, those are synthetic, and one of the things that Percona have worked on is to provide a profile that mimics the TPCC. The TPCC is a standardized benchmark for a much larger workload, and they produce a more complex workload that could be more representative of larger systems. So we talked about a lot of things, but what are some of the general good practices that you can apply when you're running benchmarking and performance tests? The first most obvious thing is to run multiple experiments and evaluate the difference between every run, right? If you get one run which gives you 1,000 megabytes per second and another run that gives you 100 megabytes per second, what's changed? What's different? Are you just testing the cache, or are you actually hitting the disk, or are you hitting some cloud limits, for example? When you're doing all of these tests, it's really useful to monitor the utilization of other resources in the system, like the CPU and the memory, because that could actually be the ultimate bottleneck. So for example, Your client might be the client that's issuing the tests to the storage system might actually be running out of CPU, and therefore you're not testing how fast the storage system can go, but you're testing how fast the client benchmark can run. In many systems, especially where we have caches and databases, for example, ensure that there's an appropriate ramp time or warm-up time. So if in normal operations, the majority of your database is in a cache, for example, then test that scenario and let the database warm up in that environment. There's no point testing, trying to cut corners and test something that isn't reflective of your environment. And finally, be scientific. Take the measurements, especially over time. Record the metrics using things like Prometheus and Grafana, etc., and look at the time series, and understand where there are changes and whether things remain stable over time, for example, because some storage systems or some caches might degrade over time, and you can see that in your environment. And also here, if you see results that are too good to be true, they probably are too good to be true. The number of times I've seen, somebody report a benchmark saying, "Oh wow, my system just did 3 gigabytes per second, and then you kind of read a little bit further down the line, and it's talking about running this on a cloud that might, maybe max out at a few hundred megabytes a second. So clearly the test was just testing the cache and not actually testing the storage system, for example. So with that, a large part of our document actually talks about a lot of the common pitfalls and other considerations that you may want to review. The first thing is figure out what you want to test. Is it operations, or is it throughput? So for example, if you're running a database and you want to do lots of operations and transactions to your system, then test IOPS with really small block sizes and test how fast your storage system can operate in that environment. Whereas, for example, if you're doing analytics and you want to test throughput, then test it with larger block sizes that is more representative of those sorts of workloads. We talked about latency, and I'm just going to reinforce this again. Latency is one of those really important things, and almost every aspect of the storage performance is going to come down to how long it takes each operation to do. So latency is possibly the single most important thing that you'd want to monitor in these environments. And what's also important is that you monitor the distribution of the latency. So tools like FIO can also give you, the minimum, the maximum, and the average, but they can also give you a percentile breakdown. And you need to figure out if outliers actually matter to you. So for example, if 1 out of every 100 IOs is taking 10 times longer than normal because of something that the storage system is doing or something that the underlying physical system is doing, that could be problematic. Understanding the storage topology is also key, because whether data is local or in a hyper-converged environment or a remote environment can affect all sorts of things, very specifically the latency, but also the number of operations that can be done. Making sure that if you're comparing systems, you're comparing the same locality and the same number of replicas, and data protection and data reduction is also a key thing. So try and do apples for apples comparisons, especially if you're comparing or doing a bake-off between different environments. I can't tell you how often we see systems where somebody's testing a local disk versus a remote disk, for example, and not realizing that they're actually completely different topologies. The data reduction can actually catch people out quite a lot. Very often we see storage systems that actually compress data or dedupe data. So for example, if your benchmark is writing a bunch of zeros into files and all of those zeros are compressing really, really well, then your system might be giving you false performance readings because it's actually not doing a lot of work. The concurrency, we talked about things like queue depth, but it's also the number of clients and the number of backends in your environment. So make sure the storage system that you're testing can scale to the environments that you're looking to work with. And we talked about the caching. The caching is probably the single thing that catches most people out the most times, because most systems have lots of RAM nowadays. And typically, if you're testing a workload that fits entirely in RAM, all you're really doing is testing the speed of memory, right? So the general best practice here is deploy a volume or deploy a database that is multiples in size of your overall RAM. So, for example, if you're running on a 16 gig box, test a volume that's at least 50 gig in size or whatever. And of course, manage the environment. So make sure that the cloud environment and the clients that you're running have enough headroom to run those systems. So we talked about how hard some of this stuff is, and it really is kind of hard. So I put together this little tool called Volbench, which can standardize an FIO run in an environment. And I'm going to 1 second. I didn't know how to do that. I'm going to share my terminal screen. That's what I really wanted to do. Okay, so I have a little Kubernetes cluster here with 3 nodes, and I have I've started up just a blank Ubuntu pod so that we can shell into it, and that pod is running a persistent volume claim, and that is mounted into /MNT in that environment. So we'll quickly go into the shell, and what we can see is I've created that PVC on a StorageOS volume, and we have a mount point, and I'm going to run the Volbench and pass a couple of parameters. So for the sort of convenience of time, I'm specifying a file called test benchmark in the MNT file system, which I've just mounted on the StorageOS volume. I'm running a size of 2 gig with a really short ramp time and a really short runtime. So I'm breaking all the rules here because, like I said, you should have bigger volumes and run for longer periods to actually catch all of the differences that happen over time. But that would make for an extremely tedious demo. So, oh no, there we go. So here we go. So Volbench tests a few things. It will test the number of read IOPS, and it does this using 4K blocks. It does and a high queue depth, and similarly for write IOPS, it will test 4K blocks with a high queue depth to see how many write IOPS it can do. It then does a similar thing, but this time it's testing 1 to 8K blocks for read throughput and write throughput. And then it tests a low queue depth with 4K blocks to look at the latency for both reads and writes. And then it tests a mixed workload, because very often storage systems perform very differently when they have both reads and writes going on in parallel. And then just for completeness sake, we do large sequential tests with multiple jobs that test the overall throughput with 1 meg block sizes. And I'd just like to sort of highlight a few things. So what we can see is the difference in block sizes and queue depth makes a big difference. So for example, the read IOPS here is showing 33,000 IOPS, but it's actually only doing 129 megabytes per second. And that's because each IOP is only 4K. Whereas when we're testing the throughput with, when we're testing the throughput with 128K blocks, we see a much lower number of IOPS, but a gigantic amount of megabytes per second, because each block is now 32 times the size. The same sort of thing can be seen when we're looking at the latency, for example. The latency for 4K writes, for 4K reads, I mean, is going to be much lower than the latency. I apologize for my screen jumping around. For the latency for 1 to 8K reads, for example. And then at the end, what we do is we summarize all of that to give you a standardized version of the performance. So this is going to be an easy way where you can run this this test across PVCs, across multiple volumes. And in the Kubernetes world, this makes it extremely easy to test different types of storage from different providers, because you can run the same job with different PVCs, say from a cloud provider or you know, a storage system like StorageOS, for example, and actually look at the differences between the different environments. And it's a really great way of giving you an overall view of things like database performance by looking at the I/O operations, but also for analytics and things like that by looking at the sequential and throughput numbers. So hopefully that's being helpful, and I will stop for questions.
Awesome. Thank you so much, Alex. We are, in fact, pretty much out of time. So I want to make sure that we stick more or less to the schedule, but what's the best way for people to follow up with you if they have questions?
Very good question. There you go.
Cool.
So you can reach me on email or on Twitter. And we also have our team also has a public Slack, which you can reach me on. And I'm also on the CNCF Slack if you're on that community too.
All right. Fantastic. Thank you so much, Alex. Thank you for sharing this and really, really appreciate it. With that, we're now going to go to our 15-minute break. So let me just share my screen once again. Cool. Okay, so feel free to go grab some water, stand up, stretch, chill out. I'm going to head over to Rambly, this link, oishell.com/r, where we can chat together and yeah, just hang out. We'll be back in 10-15 minutes where Matt will be doing the last talk of this evening. See you in a moment. Hi, everybody. Fantastic to be back again. Thank you for holding out. We're now going to go to Matt, who is our third speaker of the evening. Matt, over to you.
Thanks, Cheryl. Right, let's get this show on the road. Okay, hopefully you're seeing my slides now. So this is me. I'm Matt Jarvis. I'm a developer advocate at a company called Snyk. And Snyk builds cloud native application security tooling. I've been around open source for a pretty long time and, worked on both operations and development. So, I've seen kind of both sides of the fence. There's a bunch of ways you can get in touch with me. And I'm sure we'll share the slides afterwards. So the story of, I guess, the last decade or so in software development has really seen the boundaries of what's an application and what is operations and what constitutes infrastructure becoming increasingly blurry. The old view of the world was that the application itself was the only piece under the responsibility of the development team, and all these other elements in the stack sat under IT operations, and security was usually a step right at the end of that deployment process. But the world we live in today is one where our infrastructure and our workloads are almost completely tied together. Everything's declared as code, everything's a software development practice, and there's really no difference between our workload, our application, and the computing infrastructure that goes along with it. And by infrastructure, we don't just mean the underlying compute technology, but also the configuration and all the operational policies that control those capabilities. And as a community of practitioners, we've discussed in a lot of detail this blurring and consuming of the boundaries between development and operations. But in lots of cases, we haven't really considered how that impacts on how we model and practice security. In a lot of organizations, security's still viewed to be this external thing that only exists when our applications are deployed and operational, but it's kind of unworkable in the era of continuous integration, continuous delivery. Development-driven teams now have responsibilities for most of our deployment stack. And so this gives those teams a lot more responsibility for ensuring that things are secure. And by the time our code and our infrastructure is deployed to production, it's really too late to deal with the implications of security issues. And we can't slow down our development velocity to introduce security gates in the way that things used to work, because velocity, getting our applications to production as quickly as possible, is clearly the differentiator for businesses to succeed in the cloud native era. So that presents us with a lot of challenges around security. How do we make sure our applications and our infrastructure are secure when our working practices are evolving into these super fast delivery pipelines? And security does still matter. As we've seen repeatedly over the last few years, security breaches can have a huge impact on businesses, both from a financial perspective in terms of impact on your bottom line and potential fines, but also on how trusted our customers see us. And trust is really one of the key metrics for businesses to be successful in the cloud era. So let's start by taking a look at the different classes of things we probably need to be looking at to make sure that we've got security considered in our workflows. And firstly, the applications that we're creating, our workloads themselves. And modern applications are usually composed of a relatively small core of homegrown code, along with a whole bunch of open source modules. And this is great news for application development, because the availability of modules and library code means we get to develop apps faster, we can write less code, and we don't reinvent the wheel all the time by solving the same problems over and over again. And anyone who develops in Java, in Python, in Node, in Go is going to recognize this pattern. And in all of those ecosystems, the number of vulnerabilities is growing. And this isn't necessarily because code's getting more insecure. It can just be there's more code being written. And we are also getting better at working out what's vulnerable. But in the end, this all means, it all translates into more opportunities for those vulnerabilities to be exploited. And anytime we pull in a library or a package into our own code base, these things can also have a large dependency tree. So there'll be things that are direct dependencies, so packages that are pulled in by that package itself. But then there are indirect dependencies, which are the dependencies of your dependencies. So potentially you can end up bringing a ton of other modules that we might not even be aware of. And so those indirect dependencies are the ones that we have much less control over. And around 70 to 80% of all security vulnerabilities can be found in these indirect dependencies. And as an example of that, we can look at this exploit from the Node community. This was introduced into NPM in 2018. And this get cookies library is supposedly a library to parse HTTP headers, but it's actually a remote code execution exploit. About 40 lines of code, processes JavaScript, executes them on the server via the use of specially crafted commands in an HTTP request. And it was hidden behind a tree of other dependencies. So it was an indirect dependency for most of these things. And then the direct dependency eventually ended up being used in Mail Parser, which has a huge amount of downloads every month. So it's pretty easy to see how in large developer communities, these kinds of indirect dependencies can be used to hide exploitable code. So those vulnerabilities in our third-party dependencies are super important because they make up such a large part of our code base. But as I said earlier, the lines between our application and the container it runs in are becoming increasingly blurred. The container is the delivery mechanism for the application. It's typically developed at the same time, maybe even by the same team. And the application is never really deployed without it. So for all intents and purposes, we can consider them basically the same thing. And like that availability of library code, the massive growth in public container registries has been, on the one hand, great for the ability to be able to run pre-packaged software super easily, download, consume it in our infrastructure. But they are also a big source of vulnerabilities. When we look at the container landscape, although best practices are emerging around things like building minimal containers, there's still a huge amount of people using containers directly from upstream repositories. And lots of them can have significant amounts of vulnerabilities in them. You know, there was a quote I heard in the last month or so that public container registries are basically just huge sources of malware. And, you know, the point is here that we're presented with lots of possibilities for attack vectors, and our developers who are building our containerized applications need to understand that that's something we have to be concerned about. And there's also a long tail of people taking the kind of path of least resistance by giving applications containers based on things like operating systems. And when we look at operating systems in general, the amount of vulnerabilities in base operating systems is really massively growing, partly because operating systems by design ship with a lot of software in them. And, you know, you can kind of say that, you know, using these general purpose containers kind of breaks the paradigm of containers, in the sense that what we're trying to do really with containers is build something really minimal, just the minimal thing we need for our application. But there's still a lot of people using these kinds of images for application deployments. And we can also see from, this is from the Snyk open source security survey in 2019, but you know, we see similar results from these kinds of surveys recently, that people don't think about emerging vulnerabilities once their workloads are in production. So that image that you used when you deployed that workload, and maybe you did scan it and it had no vulnerabilities in it, but it could have vulnerabilities in it now, because there's new things going to be discovered all the time. So if you aren't looking at those containers you already have in production, then you're never going to find out if they're vulnerable. And fixing these things isn't usually very hard. About 40% of Docker image vulnerabilities can usually be fixed by upgrading the base image. And around 20% can be fixed just by rebuilding them. A lot of containers will have some kind of upgrade step in the Docker file. So just by rebuilding that, you can often get newer versions of potentially vulnerable code. And as we've moved wholesale into the cloud and now into Kubernetes, all our configurations almost entirely in code. And that again is part of our software development workflow. And by configuration, we can include here all of our Kubernetes YAML, our Helm charts, any automation we're using, things like Terraform, and all of the policies and configuration that goes along with that. And this is a really massive growing field, as we can see from the amount of this kind of code that's in GitHub. And we're really only just starting to view that as something that we need to consider from a security perspective. Kubernetes is increasingly complex. And as we've moved the responsibilities for developing that kind of code into our development teams, there's clearly space for misunderstandings about how things work. This is compounded by things like service meshes, which are increasing that complexity even further. And when we see this much code out there in public repositories, you can again see that kind of potential risk of taking this path of least resistance, where we might be using existing code as templates and perhaps we don't fully understand how those things work. And all of these things together are very important in the security of our environments. Most breaches in the real world come from a combination of an application level vulnerability and then misconfigurations in infrastructure which allow an attacker to widen the blast radius and take control of further bits of your configuration. And as I'm sure most of us are aware who've run distributed systems in production, there are lots and lots of real world examples of these problems. Cloud credential leakages in GitHub repositories is an obvious one, and in the Kubernetes world, we see clusters being infested with crypto miner containers, and these are all to do with this misconfigurations. And when we look at Kubernetes, it's important to realize that Kubernetes doesn't give us the kind of guardrails by design. It's insecure by default, and we as users are expected to be able to make these decisions for ourselves if we're using upstream Kubernetes. So we can look at things like, by default, there aren't any resource limits set. So that means that if you don't set resource limits, a pod can consume as much resource as the kubelet will let it. And that has the potential for denial of service attacks, which can affect a much bigger scope than just your single application. And Kubernetes will also quite happily let containers run as root. And when we look at those container images in public registries, a huge majority of them are configured to run as root, and that opens up really major security implications. If we manage to compromise a pod that's running as root, we have the potential to escape the container. And so we really need to be limiting the potential for these kinds of attacks. And very few applications really require root access in order to run. Writable file systems inside containers are also a similar risk point. If our container gets compromised, this allows an attacker to download new software. Maybe I can make changes to configurations. I can explore how I can extend the exploit. And containers also have access to lots of kernel level permissions. These are configured by default in the container runtime, which capabilities things have access to, and lots of these granular permissions won't be required by your application, and they just create additional vectors for attackers to use. So now that we've looked at the kinds of things that we need to be looking at, how do we start to deal with this in terms of, kind of modern Git-driven workflows? And the emerging answer to this is that we have to shift our security practices over to the left and embed security into our development pipelines. So sharing that burden of security responsibility across all of our development and engineering teams. And this is really where this idea of DevSecOps comes into play, that we have to integrate security considerations into our workflows in exactly the same way that we kind of merge development and operations over the last few years. And when we look at the practicality of where to really start, the obvious first place is at the developer. We need developers to have insights immediately into potential security issues, but we want those things to be tightly integrated into their workflow, reducing the friction for developers to use this stuff where they're working. So that means tools that are available from local command lines and things that are integrated into IDEs. So what we're looking to do is reduce the overhead for developers to use the tools right at the start of the process before code even gets anywhere near our repositories. And this tooling that we use has to provide developers with the right information to be able to make security decisions. Most developers are not security experts. So we need to not just provide lists of CVEs, but we want tools that give us insights into how serious vulnerabilities are, how exploitable they are, and how do we go about fixing them? Because that's the key part, is how I want to know how to fix it. And we want to be looking across all those things that we identified earlier, across our third-party dependencies, our container images, and all that infrastructure code. Snyk does all this for free, but other security tools are available, and this is about looking at how what fits best into your development workflow. And our second touch point is clearly kind of Git itself. Our Git repositories are now the single source of truth for everything, so that really has to be secure. Git as a piece of software has been pretty secure over the years, and in most cases, folks are using hosted Git services like GitHub and GitLab for this, and they've also been pretty good at security. But there are definitely process-related things to consider here. Just by how Git is designed, it opens you up to certain things, and our users need to be aware of what those things are. We need to be looking at things like enforcing two-factor authentication, making sure our users have strong key security key management practices, and that they're keeping Git updated locally. And exposing private data is really the risk here, particularly in commit histories. And when we might be moving repositories around is another classic example of where we can forget that we had things in that repository before, like secrets or keys. Configuration data should basically never be in Git unencrypted, even in local repositories, because of this reason that it's so easy to leak it in your history. So we need to educate our users how to use things like Git ignore for data like that. And it goes without saying that we need strong review processes. A lot of this is kind of about the human aspect and making sure that we've defined what our process should be and that it's being followed. And where we can, again, in this idea of reducing friction for our developers to follow these kinds of practices, we want to automate as much as possible. So building security checks into things like pre-commit hooks is a one way of looking at that. And once we're confident that Git part is secure, we can start to leverage more automation here. On every pull request, we really want to be looking for those same issues that our developers might be catching at that local development stage. But this time, these are going to be automated. So, this is at the time that PR is created, we're going to scan it for those same things, because these things change all the time. So we're going to scan our images, our third-party dependencies, our infrastructure code, every time something is change is pushed. And what we also want to see at this stage is things that might have been changed upstream since a particular piece of code was committed. even if our code hasn't changed. So we want to be doing monitoring scans over time on our repositories as well. So even if we haven't had any changes to our code, we still want to be picking up those things that are dependent on it. And at this stage, if we pick these things up here, it's relatively easy to and low cost to fix, right? So this is one of the advantages of picking these things up earlier in the pipeline. And container registries also clearly fall into this category. Nothing is fixed in stone, so an image that looked fine when it was built might now be vulnerable. A lot of registries now have built-in security scanning. If your registry has that, take advantage of it, or select tools that are going to integrate into whichever registry we're using. And we want to be scanning on an ongoing basis, even if our images haven't changed. The base image that we built our image from may have new vulnerabilities, and lots of people aren't rebuilding their images unless the configuration of it actually changes. Another integration point that we want to be looking at is in our CI/CD systems. And again, here we want automated security scanning as part of our continuous integration. This is always a good point to look at things that might not have changed because we're rebuilding our code. We can catch things that have changed since it was first scanned, perhaps when it entered the source code repository. And then the final place we want to be looking is in production. Containers in production, particularly if they don't change very often, can end up with vulnerable images, as we saw in that stat from the survey. A lot of people aren't looking at things that they've already deployed to production. So here we want to be looking at the containers that are running in Kubernetes on an ongoing basis, and also to look at as a kind of belt and braces final check to look at new containers being spawned. In this space, we can also take advantage of admission controllers, things like Open Policy Agent, so we can ensure that our security policies are being reflected in the code that we're deploying. So perhaps our Kubernetes security context policies are being configured properly, that our images have been scanned upstream. We're stopping things perhaps from being deployed from registries, from public registries, and we want to actually stop things from hitting production if they don't comply. I think there's a further more emerging set of things around runtime scanning that I haven't got a slide in this deck about, but the things like Falco, where we can look at anomalous behavior happening inside our cluster. That side of things is maturing pretty fast, and is certainly something that is worth taking a look at. So the takeaways from all of this, we want to shift security left and empower our developers to make decisions about security based on modern tools and modern process. In the new world, security teams can no longer be these gatekeepers with control over deployment. Security professionals need to change to being advisors and toolsmiths as opposed to gatekeepers, which allows our development teams to deliver feature velocity and get our applications into production more quickly. And visibility and remediation of security issues needs to be baked in to each stage of our development pipelines, leveraging automation all the way through to scan our third-party open source code, container images, infrastructure code, and running containers. So thank you very much for listening. If any of this has been interesting, you can sign up for a free Snyk account, and I'm happy to take any questions.
Fantastic. Thank you so much, Matt. I'm going to share my screen now so that we can let people submit any questions they have. Please go to, once again, this Poll Everywhere link and you should see a little text box. You can type in anything that you want. So we've got about 5 minutes for questions for Matt.
It's that time of the evening.
It takes a little while for people to figure it out and type it in, so just see how this goes.
Yeah, and also you were amazing. So maybe if there is no question, it was so good. So
Thank you. That's very kind of you.
Or yeah, if people want to follow up with you afterwards, Matt, what's the best way?
Absolutely. I'm in all places. You can find me on LinkedIn. Happy to connect with folks. I'm on the CNCF Slack, on Twitter. Just search me out, hit me up, whatever. This is my day job.
Okay, maybe you are so fantastic that people really don't have any questions.
exactly, I told you, you're amazing.
That was a great presentation. In that case, I'll just stop sharing this for the moment, and I'll wrap up for the evening. So Batel, Alex, Matt, thank you all so much for coming to speak tonight. Just really fantastic, and I really enjoyed it.
Thank you.
And thank you very much. It was a pleasure to be here. Thank you.
Thank you indeed. It's always fun.
Absolutely. And thank you everybody as well for joining us across YouTube, across Twitch, and on Rambly as well. Once again, if you want to be on this to either speak or to sponsor, then you can go to cloudnativelund.com and you can sign up there, and our next available speaking slots are in June. So just plan a couple of months ahead. Lastly, we will be back on, well, next month, we will not be on the first Wednesday of the month. We'll actually be 1 week later because next month is KubeCon. So I think everybody's going to be a bit busy with KubeCon in this space. So that's why we're going to be on 12th of May, which is 1 week later than usual. For now, I'm going to head over to Rambly, which is again, oishell.com/r. Feel free to come and meet me, hang out with me there and chat. Otherwise, have a fantastic evening. Take care, and I will see you next time. Thanks so much.
Bye, everyone.
Bye-bye. Thank you, guys.